Hi, welcome to part 2. Now for part 2, we're going to take a look at some little tougher ones right here. So let's say we have the sequence a sub n equals cosine pi over n over n squared. And I want to take the limit. Now we should kind of be able to kind of reason through this one. N squared is going to get bigger and bigger and bigger as n goes to infinity. But cosine is just going to repeat itself over and over again. Matter of fact, it's going to be 1, negative 1, 1, negative 1. So it doesn't matter, the top is always going to be 1 or negative 1, but the bottom gets really big. So this should go to, we guessed it, 0. But let's take a look using our limit process. We take the limit as n goes to infinity. And if I plug this in, I get the cosine of pi n over n squared. And again, we have to write the limit process, even though we know what's going to happen. Well, the top just oscillates between negative 1 and 1. But the bottom, if I plug it in, goes to infinity, just like we said here. But we have to show it with the limit process. So that's going to equal 0. And because 0 is finite, we say therefore the sequence converges to 0. Kind of neat. So let's take a look at another one that will diverge. Let's take a look at number 6 here. A sub n. Let's say we want to go, let's say negative 1 to the n. Let's say plus 3. Something like this. Now, if I take the limit as n goes to infinity, and I write this out, negative 1 to the n plus 3, well, it's kind of hard to see. Well, as n goes to infinity, remember, if n is 1, that's a negative 1. If n is 2, it's a positive 1. And 3, it's negative. 4, back to even. So this negative 1 is just going to oscillate. This just alternates, or what we call oscillates, between negative 1 and 1. Negative 1 or 1. And that's it. So my first term in my sequence, if I were to list it out, would be negative 1 plus 3. My second term would be positive 1 plus 3. Whoops, not a comma there. My next term, negative 1 plus 3. And my next term, positive 1 plus 3. And so on and so forth. So it's basically going to be 2, 4, 2, 4, and so on and so forth. Well, this oscillates. It just oscillates, and therefore is not finite. When you're finite, you're going to be a number. You're going to pick one or the other, not both. So this is finite, and therefore this sequence diverges. And there's our answer. So a little bit of work there. Now for number 7, let's take a look at an oscillating function that will converge, sorry. Let's take a look at a sub n equal to, and if I take something like this, let's say I do negative 1 to the n over n. Now this too will oscillate. Matter of fact, if I list out my next few terms, we can see, alright, if I let n equal 1, I'm going to get negative 1 over 1. If I let n be 2, I get 1/2. If I let n be 3, I get negative 1 over 3. And if you notice, that bottom's getting small. This bottom's getting bigger, but the top is just saying 1 or negative 1. So even though it oscillates, because the bottom is getting so big, matter of fact, my next term, 1/4. My next term after that, negative 1/5. Because that bottom term is getting so big, this will eventually reach 0. And we can do the limit process on this as well. The limit as n goes to infinity of negative 1 to the n over n just becomes, remember, the top just oscillates between negative 1 and 1. It's just negative 1 or 1. But the bottom goes to infinity. Therefore, it's 0, which is finite. And because it's finite, therefore we can say the sequence converges to 0. Very easy. Don't forget the rest of the word. Is finite. Is not finite. Don't forget those. Alright. If you go to part 2, there's just a few examples, and try some more. There's some on your homework, okay? What's in the books. So do me a favor, if you want to, go to part 3, and I'll show you how to find the sequence on the TI Nspire. So, alright, I'll see you there. Bye-bye.